Welcome to our experiment where we explore resistance per unit length of a potentiometer wire. I will demonstrate how to set up the apparatus, take measurements, plot a physics graph, and calculate the slope. Let's roll. You are provided with a potentiometer wire PT, a jockey. This is the jockey. A key for opening and closing the circuit. A standard resistor R of 2 ohms. A voltmeter V. A source of EMF. So we have two cells. This is the positive terminal of the cell and this is the negative terminal. And this is a cell holder. This is the positive terminal and negative terminal. So we fix the cell in the cell holder such that the positive terminal of the cell goes to the positive terminal of the cell holder and then the negative goes to the negative. Then we fix the other cell in the cell holder in the same way. Then we join the positive terminal of one cell holder to the negative terminal of the other cell holder to form a battery of two cells in series. And this is our source of EMF. And some connecting wires. We are going to connect the positive terminal of the battery to the positive terminal of the voltmeter and the negative terminal of the voltmeter to the negative terminal of the battery and record the EMF. So the voltmeter reading V0 is 3.16 volts. Use the electrical components provided to set up a circuit as shown in the diagram, leaving the key open. So this is the diagram. In the diagram, we have the potentiometer PT, and this is it. We have the resistor. This is the resistor. And we have the key here. This is the key. And the source of EMF. This is the source of EMF. For the source of EMF, this is the positive terminal and this is the negative terminal. And also we have the jockey here. And we also have a voltmeter which is parallel to the resistor. And the lines represent connecting wires. So we are going to join them with connecting wires. So we start from the potentiometer and we go to the resistor. And from the resistor to the key. And from the key to the positive terminal of the source of EMF. And the jockey should be connected to the negative terminal of the source of EMF. and the voltmeter is parallel to the resistor. So we have a complete circuit here. Close the key. Place the jockey at a point Q on the potentiometer wire such that PQ is equal to L is equal to 20 centimeters. So we are going to measure 20 centimeters from this direction and place the jockey on the potentiometer wire. So we close the key and place the jockey at 20 centimeters. And we are going to record the voltmeter reading. So for the voltmeter reading, we have 1.71 volts. And the length of the potentiometer wire is recorded in meters. That is 20 centimeters divided by 100 will give us 0.20 meters. And this is the voltmeter reading. The first trial, we are going to repeat the experiment again and find the mean of the two voltmeter readings before we evaluate Vin inverse. So this is the length of the potentiometer wire in meters. This is the voltage, the first trial in volts, the second trial also in volts, and this is the mean of the two trials, and this is the inverse of Vin. Repeat the procedure for L is equal to 30 centimeters, 40 centimeters, 50 centimeters, and 60 centimeters. For each case, record the value of Vin and evaluate Vin inverse. So we place the jockey at 30 centimeters and we have 1.67 volts. And again, we move to 40 centimeters and we have 1.61 volts. We move to 50 centimeters and we have 1.56 volts. And finally, we move to 60 centimeters and we have 1.51 volts. But we are going to repeat it again in order to reduce error. And so we place the jockey at 60 centimeters and we have 1.51. We move to 50 centimeters. We have 1.56 volts. We move to 40 centimeters and we have 1.61 volts. And then we move to 30 centimeters and it's 1.65 volts. And finally, we move to 20 centimeters. And we have 1.70 volts. What is happening is that as the length of the potentiometer wire increases, the resistance of the wire also increases. And so the value of V decreases. So we tabulate the results and find the mean of V1 and V2. That will be 1.71 plus 1.70 divided by 2. And we have 1.71 in 2 decimal places. And we find the mean of these two values too. We have 1.66. The mean of these two values will be 1.61. The mean of these values will be 1.56. And that of this is 1.51. And we evaluate V inverse. That is 1 divided by V. So 1 divided by 1.71 is 0.58 to 2 decimal places. And 1 divided by 1.66 is 0.60. 1 divided by 1.61 is 0.62. 1 divided by 1.56 is 0.64. 1 divided by 1.51 is 0.66. And we are going to plot a graph with V inverse as ordinate, that is the vertical axis, and L as abscissa, that is the horizontal axis. So for the plotted values, we need the values of V inverse. For the first value, we are going to move this point 1, 2, and record the value as 58 times 10 exponent negative 2 per volt, which means that when we multiply 58 by 10 exponent negative 2, we will have 0.58. So for the next value, we move the point 1, 2, and we have 60. The next one will be 62, the next one 64, and 66. So we see the values as whole numbers. But when we multiply them by 10 exponent negative 2, we have their corresponding values on the table. We also need the values of L. And we move the point 1, 2, and record the first value as 20. Also times 10 exponent negative 2, and the unit is meters. So the second value will be 30, the next one 40, the next one 50, and 60, which means that 20 times 10 exponent negative 2 will give us 0.2. So we plot these values on the graph. So we draw the vertical and horizontal axis. And we are plotting V inverse on the vertical axis. Don't forget to indicate that you change to standard form by multiplying by 10 exponent negative 2. And the unit is per volts. And also we are plotting L on the horizontal axis. So we choose a scale. We'll choose a scale of 2 centimeters is to 2 times 10 exponent negative 2 per volt on V inverse axis, and 2 centimeters is to 5 times 10 exponent negative 2 meters on L axis. So for V inverse axis, we can start from 50, since the question did not direct us to start from the origin. We can start from any convenient place. So 50, and the difference is 2. So the next one will be 52, 54, 56, 58, and so on. And for L axis, we can start from 20, and the difference is 5. So the next will be 25, 30, 35, 40, and so on. For the first point, we have 58 on V inverse axis. This is 58. And 20 on L axis. This is 20, so they will meet here. So we'll put a point there. The next one 60, this is 60 on V inverse, and 30, this is 30, so they will meet here. The next point 62 on V inverse and 40 on L is meeting here. 64 is here and 50, they will meet here. And the last point we have 66, this is 66 on V inverse axis and 60 on L axis, so they will meet here. And we draw the line of best fit. Determine the slope S of the graph. So for the slope, we draw these horizontal and vertical lines to form a triangle with a line of best fit. We name here A, we name here B, and here C. The slope is given by change in BC over change in AB. For change in BC, we have, this is the middle of 64 and 66, and so is 65, minus the middle of 58 and 60 is 59. We converted it to standard form, so times 10 exponent negative 2, and don't forget the units per volts. And for change in AB, we have 55 minus 25 times 10 exponent negative 2, and the unit is meters. So times 10 exponent negative 2 can cancel out. 65 minus 59 is 6. 55 minus 25 is 30. And don't forget the units. 6 divided by 30 is 0.2. We have per volts at the numerator and meters at the denominator. So the reciprocal will be per meters. So this is the slope. From the graph, determine the value of V when L is 45 centimeters. So we have L is equal to 45 centimeters, but we have to change it to meters by dividing by 100. So we have 0.45 meters. And we change it to standard form by moving this point 1, 2, and recording this as 45 times 10 exponent negative 2 meters. So in that case, we can locate 45 times 10 exponent negative 2 meters on L axis and draw a vertical line to meet the line of best fit, and then project it to the V inverse axis. That will be 63. So from the graph, when L is 45 times 10 exponent negative 2 meters, V inverse is equal to 63. Don't forget times 10 exponent negative 2, and the unit is per volts. And 63 times 10 exponent negative 2 is 0.63. So we have V inverse and we are looking for V. So we take the inverse of V inverse, we have V, and the inverse of 0.63 is 1.59, and the unit is now volts. So from the graph, when L is equal to 45 centimeters, V will be 1.59 volts. Given that S is equal to delta over V naught times R, calculate the value of delta. So we have S is equal to delta over V naught times R. So we cross multiply, and delta is equal to the slope times V naught times R. And we know all these values. The slope is 0.2 per volt per meters, and V naught is 3.16 volts, and R is 2 ohms. That is the value of the fixed resistor. V naught is the value of the EMF, and R is the value of the resistor used for the experiment. And so we multiply the values. 0.2 times 3.16 times 2 will give us 1.264. Volts will cancel per volts, and we have ohms per meters.